Welcome aboard Rocket Ship, the platform with the most relevant content for competitive examinations. This is Rocket Ship IAS Lab, and we are introducing the 115th lecture in our ongoing series on answer writing for general studies papers of civil service main examination. You might encounter this question in GS paper 3. Please read out the question carefully. India's three-stage nuclear power program is not restricted to a pursuit of energy security. Explain. Briefly discuss the progress made towards operationalizing the program. Before we start introducing our answer, we have to yet again remind you that it is the GS paper 3 that you might find the most difficult part of your entire UPSC journey, because the questions that appear in GS paper 3, they require certain kind of specific and moreover some kind of technical knowledge. That is, you cannot work around or rather play around with the questions that appear in GS paper 3. You have to be absolutely certain about many concepts, many for example terms, etc., that you might encounter in GS paper 3. That is why we would once again advise you to appropriate to like adequately, you could say, give out some time for GS3. Specifically for GS3, you have to have always apportion some time for GS paper 3 preparation. Anyway, we are introducing our answer with a basic observation, that is, it is the quest for cleaner, low emission power generation due mainly to the specter of climate change, which has renewed interest in nuclear power. Now, to be more specific, considering that India has barely 2 to 3% of the world's uranium reserves, experts assert that India should look for alternatives to uranium fueled nuclear power. We are taking it for granted that most of you are aware that for now, nuclear power generation mainly depends on uranium as its fuel. And as we have just observed that India has barely 2 to 3% of the world's uranium reserve. That is, it is forced to import most of its nuclear fuel. And that is why many experts assert, they argue that India should focus on exploring alternatives to uranium. For India, fortunately, this obvious choice is thorium, whose atomic number is 90. It is readily available. What are the attributes that make thorium and a lucrative alternative for India? First, it is readily available in the form of the mineral monazite found in beach and river sand. That is, monazite is an ore of thorium. It is the ore of thorium, and monazite is found widely across India in beach and river sand. Actually, by most estimates, its biggest reserve is in the beaches of Kerala. India has probably the largest reserves of thorium in the world, accounting for 20 to 25%, almost a fifth or a one-fourth of world's proven thorium reserves. Realizing the potential of thorium reactors, scientists like late Homi Jahangir Bhabha, who is considered the father of the nuclear program of India, father of the Indian nuclear program, had argued for a three-stage nuclear power plant for India, with thorium reactors becoming the mainstay of the ultimate or the final stage. So what are the three stages of India's three-stage nuclear power plant? Actually, we are categorizing these stages, we are dividing these stages according to the main fuel that they would be using. In the first stage, it is uranium, that is the isotope of uranium with atomic weight 235, that is uranium 235, that would be used as the fuel for the first stage of nuclear reactors. In the second stage, it would be plutonium based breeder reactors. They would use 238, they would actually use uranium 238 and react it with neutrons to give out plutonium 239, which is a fissile material. That is it is actually amenable to fission, that is division, and produce, that is nuclear division, and produce energy. In the third stage it would be thorium based, where thorium 232 would be reacted with slow neutrons to give out uranium 233, which is a fissile material. And we would actually advise you to it would be at your comfort level that whether you include these equations in your answer or not. You may actually opt for not introducing or not including these equations in your answer if you are in a sort of time and space. Anyway, sorry, I have a bad cough today actually. It is well regarded that thorium reactors would reduce dependence on imported uranium, ushering in energy security. Actually, this is considered the main, you could say, supporting argument for going for thorium based reactors. However, the benefits of thorium based reactors go beyond energy security. So what are the probable benefits of the three-stage nuclear power program which go beyond energy security? These are: first, it is considered much more environment friendly. Why so? Because the waste material that is generated by the thorium reactors, it disintegrates to safe levels quickly. As we would see later, actually the present day uranium reactors, the waste that they generate, it may take even centuries to come back to safe levels, which is in contrast to the thorium based reactors, which whose waste material would reach this safe level in less as a decade. The thorium reactors are much less susceptible to nuclear proliferation, that is clandestinely sharing nuclear technology and material with non-nuclear states, which Pakistan and North Korea have often indulged in. Because it is much less susceptible to nuclear proliferation, because it produces much less weapon grade material. It also cements India's dominant place in nuclear technology. Actually, India is considered a world leader in thorium-based nuclear technology. And if India actually demonstrates the viability of thorium reactors, it would mean that most of the countries would consider India among the technology leaders, nuclear technology leaders. Moreover, thorium technology, it opens exports opportunity for India, and if India were to share this technology with emerging and in some cases even the developed nations, it would earn India a lot of goodwill. So now, detailing on these points, sorry, waste material from nuclear reactors fueled by thorium are easy to manage. The half-life is in decades, unlike uranium reactor waste that may take centuries to come to safe levels. So that means that within say a few decades, the waste material is easy to dispose of actually. While thorium reactors, they do indeed produce sorry, they indeed produce weaponizable isotopes, but it is as less as 2% compared to plutonium reactors. This reduces risk of nuclear proliferation. That is, nuclear proliferation is the term that is used for clandestinely sharing nuclear technology or material with non-nuclear states, and in fact between a nuclear state and non-nuclear state. Thorium research is one of the few areas India leads in. Demonstrating their practicality, that is demonstrating their viability, would earn us a high place as scientific and technology superpower. This would demonstrate that India has arrived on the scene of technology superpower status. Cleaner, safer, affordable thorium reactors can open export markets for India. Sorry again. Sharing this technology will also earn India much goodwill among the nations of the world with its partners and potential allies. Now, to conclude, there has been some progress in, now talking of the progress that we have seen in the three-stage nuclear program. There has been some progress in actualizing the three-stage program. The prototype fast breeder reactor, that is PFBR, which is set up in Kalpakkam near Chennai, is set to enter a stable operation phase. That is, it is often called criticality. It is set to enter criticality stage. Why are these reactors called fast breeder reactors? Again, they are called fast breeder reactors because they use fast neutrons, unlike the slow neutrons that are used by uranium reactors. The breeder reactors, they use fast neutrons, and they are called breeder reactor because hypothetically they produce more fuel than they actually consume. We would repeat it. They are called fast reactors because they use fast neutrons as compared to the slow neutrons that are used as trigger by the uranium reactors. Moreover, they are called breeder reactors because they hypothetically breed, that is, they generate more fissile material than they actually consume for producing energy. This shows progress towards second phase. Now, we have already demonstrated that we can move to the second phase. Now, talking of the third phase, that is, there is a proposal to build 300 megawatt advanced heavy water reactors, that is AHWR, which would be majorly fed with thorium. So the point is, there is a proposal to build a 300 megawatt thorium fueled advanced heavy water reactor. And if India actually manages to demonstrate the viability of this AHWR, that would send a message across the world that India has arrived on the scene of thorium research, and in fact the thorium reactor is a viable concept. That is the point we were arguing about, the benefits of India's three-stage nuclear program that goes beyond energy security. We have seen how, for example, it would be much more safe because it would be much less amenable to proliferation. It would be environment friendly because the isotopes that are generated as waste would come back to safe level in much less time than compared to the uranium reactors. Moreover, it would also mean that India would have an opportunity of sharing the technology either on commercial basis or for as a matter of generating goodwill for India, sharing it with our potential allies and partners. So this was all on the benefits of India's three-stage nuclear power program, and we have actually discussed quite many technical details about the three-stage program. This is all for today. We would reassemble for the next lecture in a few days. As usual, we wish you all the best. Thank you.